Section 1.4, solving equations. More of that Algebra 1 review as we start Algebra 2. So here we're just asked to solve. I'm going to go through these kind of quickly, but if you need to, you can always pause the video. So x plus 4 equals 12. The key here is to use your inverse operations. So to get rid of the positive or the adding of 4, we'll subtract 4. And so x equals 8. Question B, same idea. We're looking to solve for the variable, in this case, y. I have negative 27 plus 6y equals 3 times the quantity y minus 3. So I'll start the solving process. I'm going to go and distribute this 3. So 3y minus 9 now equals negative 27 plus 6y. Let's get the variables to one side, constants to the other. So to do that, I'll subtract 3y from both sides to bring my y's to the left. Negative 27 plus 3y equals negative 9. Then I'm going to move the negative 27 by, in this case, adding a positive 27 to cancel on the left. So now I've got 3y equals 18. I'll divide by 3. And y equals 6. Example C, we have more of the same. We'll go ahead and distribute first. So in this case, we're going to distribute the 3. So that's 6x minus 3. I'm going to distribute the negative 2 throughout. So that's going to give us negative 6x minus 8 equals 11. On the left, we'll go and combine like terms. We've got 6x and negative 6x, which is going to be 0. So the x's on that side just disappear. Realizing now that I forgot the x on the 11 there. Okay. So the x's here are going to cancel out. We have negative 3, negative 8, so it's negative 11 equals 11x. Last step, get the x by itself, so we divide by 11. And we get negative 1 equals x. Here we're dealing with a word problem, everyone's favorite. It says the garden has the dimensions shown. If the garden has a perimeter of 200 meters, what are the dimensions of the garden? First thing we need to remember that to find the perimeter of, in this case, a rectangle, perimeter equals, you can either do length plus width, or you can do 2 lengths plus 2 widths. In this case, we'll go x is the width, 3x is the length. So now we just need to plug in what we know in order to solve for the actual dimensions. We know the perimeter is 200 meters. So 200 equals 2 times 3x plus 2 times x, or in this case, just 2x. Here we can simplify. 2 times 3x is 6x, so 6x plus 2x equals 200. This gives us 8x. 8x equals 200, so that means we're going to divide by 8. And in this case, so x equals 25. So that means our width in this case is 25, and I'm not certain if it's feet, meters, what, so we can just say 25 meters. And then in this case, 3x, that tells us that the length would be 75 meters. Here we're talking about equations with no solutions or identities. So sometimes we'll have equations where the variables will disappear, and then the statement left behind is either going to be true or false. If it's true, meaning that both sides match up, we have what they call an identity, where there's an infinite number of solutions to this problem. If it's false, we have what we would say was no solutions. So let's look at example A. We have 11 plus 3x minus 7 equals 6x plus 5 minus 3x. The goal here, let's just go ahead and clean up the two sides. We'll combine like terms. We've got 11 and negative 7, so that's going to give us 4 plus 3x equals, and then on the other side we've got 6x and negative 3x, so that's just going to give us 3x plus 5. Now we're just going to go ahead and try to simplify. Well, I'm going to get my variables together, so I'll subtract 3x from both sides. And this is when I notice something special. I've got 4 equals 5 because the 3x is canceled out. So then I have to recognize this is a false statement, or it's never true. So in this case, this would be no solution. Question B, same idea. We've got 6x plus 5 minus 2x equals 4 plus 4x plus 1. So let's clean up the two sides. We've got like terms. So 4x plus 5 equals, in this case, 4 and 1 on the other side. That becomes 5 plus 4x. They already match. They're just written differently, so we kind of know where this is going. Subtract 4x. And we've got 5 equals 5. Well, this matches, and this is true. 5 is always going to be equal to 5, so this is an identity. I spelled that wrong. There we go. Literal equations, an equation that uses at least two different letters as variables. So with literal equations, we can also refer to them sometimes as formulas. What we're looking at here is rewriting an equation or a formula for a specific variable. So for example A here, I have C equals 5/9 times F minus 32. What is F in terms of C? Meaning we want to get the variable F by itself. To do this, the first thing we would do naturally would be to, in this case, get rid of the 5/9. Well, to do that, let's go back to our original here. So what we're going to do here is we're going to multiply by the reciprocal. So in this case, we're talking 9/5 on both sides. So we see a cancel, and we've got 9/5 C equals F minus 32. Now to get F by itself, we're going to move the 32 by adding it to the other side. And this is going to cancel here. And so what we're left with is, and I'm going to rewrite this, F equals 9/5 C plus 32. Question B is very similar. We're going to, in this case, what is C in terms of K? So we're trying to write C as the lone variable and everything else on the other side. So in this case, if we start off here, we've got K equals C plus 273. What we want to do is get C by itself, so we're going to subtract 273 from this side and cancel. And we've got K minus 273 equals C. We can also write it this way, C equals K minus 273.